Question 8. Express a squared brackets 2a to the power of negative half plus a in its simplest form. So to do that, we need to multiply out the brackets. So when you're multiplying a squared and a to the power of negative a half, you've got to add the powers. So it's 2 plus negative a half. That's just going to become 2 take away a half. Now we've got a whole number take away a fraction, so we can just turn that into a fraction by putting that over 1. Make an equivalent fraction by timesing the top and the bottom by 2, so that's going to be 4 over 2 take away 1 over 2 equals 3 over 2. We've got our 2 at the front here as well, so it's going to be 2a to the power of 3 over 2. We then need to multiply these two terms together. Now you'll notice a doesn't have anything written as a power here, that just counts as being a 1. So you add the powers again, 2 add 1 gives you 3. So it's plus a cubed. Part B, completely unrelated to part A, use an appropriate formula to solve the quadratic equation, 3x squared plus 3x minus 7 equals 0. Well, to solve these, they have to be equal to 0. It already is equal to 0, so that's fine. So we're going to use the formula x is negative b plus or minus root b squared minus 4ac all divided by 2a. Now that's in your formula sheet. So a is equal to 3, b equals 3, and c equals negative 7. So we're going to substitute that into here. So it's negative 3 plus or minus the square root of b squared minus 4 times 3 times negative 7, all divided by 2a. So let's tidy all that up. It's important you write this bit that's called the discriminant, just tidy it all up into one number. So negative 3 plus or minus the square root, so 3 squared is 9. Now it's negative 4 times 3 is negative 12, and negative 12 times negative 7 gives you positive 84. We'll divide all that by 6. So we're going to have negative 3 plus or minus the square root of 93, all divided by 6. So we're going to do two calculations. We're going to work it out where we're adding and one where we're subtracting. So negative 3 plus square root of 93 over 6 is 1.107. So as it says there, one decimal place, that's 1.1. We're also going to do it when it's a minus, so minus root 93 over 6, and that's negative 2.107 or negative 2.1. So those are two answers. It's not asking us to give it as coordinates or anything like that. So just our two values. Put x there as well, just to be a bit more accurate. Next, we've got to solve the equation 4 tan x plus 5 is equal to 0. Now to solve these, we want to make x a subject, so let's just make tan x a subject first. So we're going to subtract 5 from both sides. Divide by 4. Now there's more than one way of doing this. My preference is to use what a lot of people refer to as a cast diagram. So tan is negative. So if it was positive, we'd tick these two quadrants, they're all on tan, but it's negative, so we're going to tick off these two. So I'm going to say x equals the inverse tan. Now I don't put the negative in ever when I'm doing this, and this gives me an answer between 0 and 90 degrees. So when I work that one out, it comes to 51.3 degrees. Now that's not one of the solutions I'm after, because that's between 0 and 90 in the all section. I want an answer between 90 and 180 in here, and between 270 and 360 in here. So I've got to take this, I'm going to subtract it from 180 and subtract it from 360. So my two answers are 128.7 and 308.7, and those are both between 0 and 360. I don't need anything bigger than that or less than that. Those are just the answers between 0 and 360. Part B. Tan x cos x equals sin x. So we've got to show that this is equal to sin x. That's what we want to end up with. Now these questions are going to use one of these two trig identities. You can usually tell which one to use just by having a wee look at the thing you're starting off with. It mentions tan, there's no squaring in there at all, so there's no squaring, so that's probably an indication you're not going to need to use this one. It's got tan in it, so an indication you're going to use this one. So tan x cos x, well I know what tan x is equal to. It's equal to this. So I'm going to replace tan x with sin x over cos x. And that's multiplying cos x. So for multiplying and dividing by cos x, those cancel each other out, leaving us with just sin x, which is what we wanted in the first place.